Okay, so now let's look at an example. Suppose that on average, 2.1 customers arrive at a restaurant every 15 minutes. Let's first find the probability that there are 2 or fewer customers in 15 minutes. So now if I let x be the number of customers, then x is a Poisson variable, right? Or it has a Poisson probability distribution. And so suppose we want to construct the probability distribution of x, then we have x on in one column, and then we have the probability that x is equal to a particular value x sub k in the other column. As we discussed in the past, x can be 0, so nobody shows up in 15 minutes. There could be one person who shows up. We could have 2 people, 3 people, 4 people, and so on and so forth, right? So the table goes on forever. And associated with each of these numbers is a probability. Okay. So now the question says, what's the probability that there are 2 or fewer customers in 15 minutes? So the probability that we're looking for is the probability that x is less than or equal to 2, right? That means 2 or fewer. Now, when we have 2 or fewer, that means we must have 0, 1, or 2. Right? In other words, if you go to the table here, the probability distribution that we have, we're interested in this range of numbers, right? Where x is 0, x is 1, and x is 2. And so to do this kind of problem, all you have to do is to add up the probability of the individual numbers. So here we're going to have the probability that x is less than or equal to 2 is going to be equal to the probability that x is 0 plus the probability that x is 1 plus the probability that x is 2. Okay. Now at this point there are 2 ways to proceed. The first way for you to proceed is to plug numbers into the formula that we had, and then do the calculation and get the answer. Okay. An easier way, in my opinion, is to use the Poisson table. And to use the Poisson table, we need to identify the mean number of occurrences. And the problem tells us that that value is 2.1. So 2.1 here is mu, right? So now let's go to the table. What I want to look for is I want to look for column labeled 2.1. So it's going to be this column, right? And then I'm interested in the probability that x is 0. So in this case is 0.1225. The probability that x is 1 in this case is 0.2572, and then the probability that x is 2, which is 0.27. Okay. So we have 0.1225 plus 0.2572 plus 0.27, and if you do the math, you get 0.6497 as the answer. Okay. Okay. So what do we learn here? What we learn here is that the probability of a range of numbers, so the probability of a range of number right, is equal to the sum of the probabilities of the values in that range. So here we wanted to find the probability that x is less than or equal to 2. When x is less than or equal to 2, we're thinking 0, 1, and 2. Right? And so the probability that x is less than or equal to 2 is going to be the sum of the probability that x is 0, the probability that x is 1, and the probability that x is 2. Okay? Now let's do a follow-up question. Let's find the probability that there are 3 or more customers in 15 minutes. Okay. So now let's look at the question and identify the probability that we're looking for. So here we have 3 or more. That means that we want to find the probability that x is greater than or equal to 3. Right? 3 or more means it's 3 or above. Now if we apply the same principle that we talked about in the previous part, then what you want to do is you want to take the probability that x is 3 plus the probability that x is 4 plus the probability that x is 5 plus ... And this list never ends because we have an unlimited number of possible values for x. Now, if you take a second and think about it, this is not a feasible way for you to do this problem, right? You cannot sit here and do math for the rest of your life, right? So there must be an easier way to do this. How do we actually approach this problem? Let's remember that this is a probability distribution, right? This table right here. And so for a probability distribution to be valid, the sum of all the probabilities have to be 1. Right, so sum to 1. Okay? But then what are we interested in? We're interested in the probability that x is greater than or equal to 3, which means that we're interested in the sum of the numbers in the box. Okay? But let's take a look at this. The sum of the numbers in the box plus the probability that x is 2 plus the probability that x is 1 plus the probability that x is 0 sum to 1. That sum is equal to 1. Right? So let me write that down. Let's say alternatively, right, the probability that x is 1 is 0 plus the probability that x is 1 plus the probability that x is 2 plus the probability that x is greater than or equal to 3 is equal to 1. And so to find the probability that x is equal to 3, we take 1 minus the probability that x is 0 minus the probability that x is 1 minus the probability that x is 2. Okay? Essentially what I did was I subtracted those numbers from both sides of the equation. Right? But then we know the probability that x is 0 is 0.1225. Right? We know the probability that x is 1 is 0.2572. And then we know the probability that x is 2, which is 0.27. Right? And so if you do the math, you're going to get 0.3503 as the probability that we have 3 or more customers in 15 minutes. Okay, so the idea of this question is that whenever you want to find the probability that x is greater than or equal to a particular value, here we have the probability that x is greater than or equal to 3. What you want to do is you want to take advantage of the fact that the sum of all the probabilities is equal to 1, and so you would take 1 minus the part that we're not interested in. Okay.